Hey, all right, so here we are with EFM lesson 2, weight and mass. So in the notes, I've already kind of filled this in for you. Weight, so we want to differentiate the difference. Obviously, it's what differentiate means. We're looking at the difference between weight and mass. They're not the same thing, but they get confused pretty often. So for weight, we know it's the measure of gravity pulling on an object, including you. So gravity is always pulling you down. We measure weight in newtons, capital N. Since gravity is a force, again, we measure it in the Newton. Weight is a measure of the force of gravity. So it sounds repetitive, just said in some different ways. Compression of a scale is proportional to weight. So again, pushing things together, you're compressing it. Sorry, apparently I can't use my words today. It's proportional to the weight. So the amount of gravity pushing or compressing on an object is going to be proportional to its weight. That's why you don't get squashed. That's why objects don't get squashed on Earth, because there's an equal force pushing out on the object as well as gravity compressing or pushing in on the object. There's a balance. Everything in nature always wants to be in balance. It's called equilibrium. Everything in nature always wants to be equal, always wants to be in balance. Now, mass, we're looking at the measure of the total matter that makes up an object. That's why you can have, say, two boxes that are the same exact size, the same exact color, shape is the same, everything about the boxes are the same, but you pick one up and it's super, super light. You pick another one up and it's super, super heavy. And that has to do because the box that's light, maybe that box is made of cardboard, super, super light. But maybe the other box then is made of steel, which would be super, super heavy. So when we get into chemistry and we start looking at different types of matter, elements, and we look at how different atoms are made, have different masses, we start to see why certain objects have more mass than other. We measure mass in grams. So again, weight is measured in Newton, mass is measured in grams or kilograms. We use a balance to find mass, not a compressional device. So in class, we would use a digital scale. We could use a triple beam balance to measure mass of objects. For weight, we can also use a digital scale, but your scale now, unless you have a digital scale at home, if you have a scale that you weigh yourself on, a lot of times there's a spring inside, and that's how we measure weight. But now with the digital scales, you can measure your body's mass and you can tell what's muscle, what's fat, what's water, and muscle has a mass and it has weight that is significantly more than like fat and water. Mass is not dependent on gravity. Super, super important. So weight is dependent on gravity. Mass is not. So highlight that, take note. Mass is not dependent on gravity, but weight is. All right, so you need your calculator for this. And this is it's a fun activity, but it is something to help solidify in your brain, get it packed in there that your weight can change on other planets, but your mass is not going to change. So, and it's like, I don't know how much I weigh, Miss Bonifino. It doesn't matter. You can make it up. So if you weigh, I don't know, 98 pounds, all you're doing with your calculator is typing in 0.17 times your weight, say it's 98, and what does that equal? And that'll tell you how much you would weigh on the moon. Now, your body's not going to change, but your weight is going to change. Then also calculate it on Neptune, Jupiter, Pluto, and the sun. your weight is going to be significantly more on the sun. That doesn't mean all of a sudden your body has quadrupled in size. It's just the force of gravity acting on you. So go ahead and you can pause and calculate your weight on other planets and the sun. I hope you did your calculations if you're at this part. So for some further explanation, you can go to this link. And this is what you'll see at first, your weight on other worlds. You enter your weight here and click calculate and scroll down. You can see other planets and other celestial bodies like a neutron star. I think they have the sun on there. So you're going to see some outrageous numbers, which is always fun to see. So go ahead and try it. It doesn't take long, and feel free to put some different weights in there just to see how that works. Okay, so you should be done calculating your weight on other planets using that link I gave you to calculate your weight on all the planets and other celestial bodies out in our solar system and in our galaxy. You'll notice this is in yellow. So weight is dependent on gravity, mass is not. I have it here twice. Super, super important. You need to download this into your brains. Weight is dependent on gravity, mass is not. So, something cool, which is a true story, on Earth, your weight is slightly less at the equator and slightly more at the North or South Pole. And this has to do with the differences from the distance from the center of the Earth. So I hope you learned this in Earth Science last year, that when our planet is spinning, um, it kind of compresses at the poles. So if you were to spin a ball really, really fast because it's spherical, and you were to spin it really, really fast, you would see at the poles it is compressing and that there's this bulge at the equator. So as we know, gravity is pulling us towards the center of the earth. Well, if we're a little bit closer to the center of the earth, our weight's going to change. It's going to increase. And if we're further away, our weight's going to slightly decrease. Now, it's not a huge thing. You're not going to go to the equator, and if you weigh 98 pounds, you're not going to suddenly weigh 50 pounds. It's a very slight difference. But go ahead and watch this. It's a really good demonstration on an oblate sphere, which is what our planet is while it's in motion. It's called an oblate sphere. Okay, I hope you watched that. I hope you paused and watched that. Last little bit of notes on gravity. So gravity can be defined as the force of attraction. The more mass, the greater the attraction. That is why your weight would be significantly greater on the sun, because the sun has more mass. So yes, the sun has more mass. Therefore, it's going to have a greater gravitational force. And that is why the planets in our solar system revolve around the sun, because it has a greater mass. Therefore, its force of attraction is greater. So every planet in our solar system is attracted to the sun because it has more mass. Ouch! The closer objects to one another, the closer objects are to one another, the stronger the gravitational pull. So Earth is the third rock from the sun. Mercury is closest. So because Mercury is closer, there's a stronger attraction between Mercury and the sun. Earth exerts gravitational force that pulls objects towards the center of the Earth. You guys know all this. You've heard this a million times. I believe it's already in your brain. And finally, gravity is dependent on mass and distance. Super, super important, just like energy, like GPE. We know that GPE is dependent on height and mass. Well, gravity is dependent on mass and distance. Okay, that's the end of our notes.